Bismillahirrahmanirrahim. Assalam O Alikum, dear student. Welcome to my YouTube channel Learn with Azam. Today we will read that new syllabus physics SSC2 unit number 10 simple harmonic motions and waves. SLO based or according to FBISE requirement. Now for a conceptual numerical in numerical problems, question number 7 to 13, part 2. In part 1, SLO based numerical problem solve question number 1 to 6. Today we will solve the question number 7 to 13. Now, in question number 7, a mass hangs from a spring, vibrates 15 times in 12 seconds. Calculate the frequency and in V part the time period of vibration. Now, according to the statement, write the given data. Number of vibrations n is equal to 15 and time for 15 vibration t is equal to 12 seconds. Required frequency in first part and in second part time period. Now using the formula for frequency according to the definition, frequency is the number of waves passing through a unit time. So F is equal to N upon T. Similarly, we can find the time period and time period is the reciprocal of frequency. So T is equal to 1 upon F. Solve in first part frequency F is equal to N upon T. Putting the value of N number of vibration 15 divided by 12 seconds. 15 divided by 12 is equal to 1.25 Hz. So the frequency is F is equal to 1.25 Hz. In V part, we can find the time period putting the values T is equal to 1 upon F. So 1 upon 1.25 dividing 1 divided by 1.25 is equal to 0.8 seconds. So the time period T is equal to 0.8 seconds. In question number 8, given statement, a spring required a force of 100 Newton to compress it to the displacement of 4 centimeter. What is the spring constant? According to the statement, write the given data. Force F is equal to 100 Newton and displacement x is equal to 4 centimeter. Now change the centimeter into meter, then 4 divided by 100. 4 divided by 100 is equal to 0.04 meter and required that spring constant K. Now using the formula, we know that F is equal to Kx by Hooke's law. Now for solution F is equal to Kx, this implies that we arrange that to find the value of K is equal to F upon X because F is multiplying in this side, on other side it will be divided. So K is equal to F upon X. Now putting the values, this implies that K is equal to F upon X. Value of F is equal to 100 and X is equal to 0.04. Now 100 divided by 0.04 is equal to 2500 Newton meter. So K is equal to 2.5 multiplied by 10 raised to power 3 Newton meter. Now we can have question number 9. A second pendulum is the time period of 2 centimeter. How long must a pendulum be on Earth? G is equal to 9.8 meter per second square, and Moon is equal to G is equal to 1.62 meter per second square. What is the frequency of second pendulum at the Earth and at a Moon? Here, given statement second pendulum. What is meant by a second pendulum? When time period is a 2 seconds, that means pendulum vibration is second pendulum. If 1 second, then first pendulum. So now we require data given that time period T is equal to 2 seconds and gravity on Earth GE is equal to 9.8 meter per second square, and gravity on a Moon GM is equal to 1.62 meter per second square. Now we can require that length of pendulum on Earth, that is equal to LE is equal to question mark, and in second part length of pendulum on Moon LM is equal to question mark. Now we using the formula and also required that frequency of pendulum on Earth FE is equal to question mark, and in fourth part frequency of pendulum on Moon FM is also required. Now we can find that by using the formula for length of pendulum on Earth LE is equal to T square G over 4 pi square, and on Moon LM is equal to T square GM over 4 pi square. For frequency on Earth FE is equal to 1 over T, and on frequency on Moon FE is equal to 1 upon T. Now for a solution, we know that time period of simple pendulum T is equal to 2 pi L over G. Taking the square root on both sides, then we have T square is equal to 4 pi square L over G. This implies that L is equal to T square G upon 4 pi square. Now for first part, on Earth LE is equal to T square GE over 4 pi square. Putting the values, then we have LE is equal to time period T 2 square multiplied by 9.8 value of G on Earth divided by 4 into pi value 3.14 whole square. Now 4 cancel out by 4, then 9.8 divided by 9.8596. Now the answer of length is 0.99 meter. So the length on Earth is equal to 0.99 meter. Similarly, now we can find the length on a Moon LM is equal to T square GME over 4 pi square. Putting the values in given equation, then length on Moon is equal to T square GME over 4 pi square. Value of time period T is equal to 2 seconds, then 2 square multiplied by 1.62 divided by 4 into 3.14 whole square. 4 cancel out by 4, then 1.62 divided by 9.8596 is equal to 0.16 meter. So the length of pendulum on moon LM is equal to 0.16 meter. Now we can find the frequencies. Then we know that the frequency of pendulum F is equal to 1 upon T, because frequency and time period both are reciprocal to each other. So for third part, the frequency on our earth is equal to Fe is equal to 1 upon T is equal to 1 divided by 2 is equal to 0.5 Hertz. Similarly, frequency on moon is also Fe is equal to 1 upon time period T. That is equal to 1 divided by 2 is equal to 0.5 Hertz. For next question, in question number 10, calculate the time period and also frequency of a populace on a plane if complete 250 cycles in 5 seconds. Here, write the given data. Number of cycles n is equal to 250. Time period for 250 cycles T is equal to 5 seconds. Required that first of all time period capital T is equal to question mark and also frequency F is equal to question mark. Using the formula we know that T is equal to T over N. T is the time and N is the number of cycles. And also we know that frequency is the reciprocal of time period, so F is equal to 1 upon T. For solution, putting the values T is equal to T upon N. Here T is the time for cycles and N is the number of cycles. So capital T time period is equal to 5 divided by 250. 5 divided by 250 is equal to 0.02 seconds. And in second part, we know that frequency F is equal to 1 upon T is equal to 1 divided by 0.02. Now 1 divided by 0.02 is equal to 50 Hertz. In question number 11, given statement, water wave with the wavelength of 2.8 meters produced in a ripple tank travel with a speed of 3.80 meter per second. What is the frequency of a string vibrating and produce then? Now, given data, wavelength lambda is equal to 2.8 meter and also speed of wave v is equal to 3.80 meter per second. Now we can find that frequency f is equal to question mark. Using the formula, we know that V is equal to F lambda. Then for our solution, we know that V is equal to F lambda. Then we find the frequency. So we rearrange F is equal to V upon lambda. Then putting the values, this implies that F is equal to V upon lambda is equal to 3.80 divided by 2.8. Now 3.80 divided by 2.8 is equal to 1.4 Hertz. In question number 12, the given statement, the distance between successive crests in a series of water wave is 4 meter and crest travels 9 meter in 4.5 seconds. What is the frequency of the wave? First of all, write the given data. Distance S is equal to 9 meter and wavelength lambda is equal to 4 meter. So we have time t is equal to 4.5 seconds. Then required that frequency f is equal to question mark. Using the formula S is equal to Vt, then we have solution. We know that S is equal to Vt. First of all, find the value of V. So V is equal to S upon T, then 9 divided by 4.5. Now 9 divided by 4.5 is equal to 2 seconds. So we have find the frequency, then V is equal to F lambda. Putting the values, this implies that F is equal to V upon lambda is equal to 2 divided by 4. Then frequency F is equal to 2 divided by 4 is equal to 0.5 Hz. In question number 13, today we will solve the last question. In this question statement, a radio frequency wave has 1230 multiplied by 103 Hz. That is 1230 kilohertz. And the FM radio station frequency is 91.9 multiplied by 10 raised to power 6, that is equal to 91.9 megahertz. So we have find the distance in crust of each wave. So write the frequency of AM radio, FM radio is equal to 1230 multiplied by 10 raised to power 3 hertz and FM radio 91.9 multiplied by 10 raised to power 6. Here 10 raised to power 6 hertz. So we have speed c is equal to speed of light 3 multiplied by 10 raised to power 8 meter per second. Now we have find the wavelength of the radio wave and also FM radio wave. Then we have find now the solution. Wavelength lambda of AM is equal to C upon FM AM. So 3 multiplied by 10 raised to power 8 divided by 1230 multiplied by 10 raised to power 3 is equal to 2.44 multiplied by 10 raised to power 2 or also equal to 244 meter. Similarly, wavelength on FM is equal to C upon F. Frequency of FM is equal to 3 multiplied by 10 raised to power 8 divided by 91.9 multiplied by 10 raised to power 6. That is equal to 0.0326 multiplied by 10 raised to power 2 meter and also equal to 3.26 meter. In next video with next lesson, best of luck, take care.